Hello and welcome to another Physical Sciences 3 lecture. Today we're moving on to electricity, but before we talk about electricity specifically, it's important that you know that about atoms and protons, electrons and neutrons. So if you've never seen them before, if we had a helium, you may have seen on a periodic table something like this, helium 4-2. This would mean that we have, in a nucleus, we would have two protons, and I've said the protons are P pluses, so that's a proton, and that would be a neutron. And then around the outside, we have electrons with little minus signs, something like that. So that we can model a helium atom like this, and we have protons in the nucleus here, and then we have electrons around the outside there, so electrons. And electrons have a negative charge and protons have a positive charge. So when we look at what this paragraph here is saying is electricity is the phenomenon of having an imbalance in charged particles. So we're talking about a proton or an electron essentially, or some sort of ion, like some sort of ion. Let's say we removed one of these electrons from the helium atom, would have an imbalance in charge there, and so it would have a charged particle. Um, and if we have two charged particles between 2 points, then or more, then we're going to have what we call electricity. Electricity can be around. So this may be seen in either two ways: static or current electricity, and is measured as voltage or the energy difference between them. Okay. Static electricity is where we have a build-up of charge on one point and a corresponding deficit charge on another. The charges are not moving between these points, and if you ever have an electric shock, that is static electricity. A current electricity is the flow of free electric charges through a conductor and requires continuous circuit and an energy source to continue the flow of charge. Let me say I should have a little. Oh, do we have a little picture down here? So something like this light bulb, we have a continuous charge going from the battery. So we have a positive charge here, and all these charges are going around this way, or the current is flowing. The convention says the current is flowing from the positive to the negative, because we have a difference in charge between this positive charge here and this negative charge point there. We have a difference or a voltage between those. So that's current, and we use current electricity most of the time, and we use electricity for two main purposes: to carry energy from hydro stations or power stations to our homes and industries for heating, or from a car battery to the starter motor, for example. Okay, so I've got a couple of those. Or we also use electricity nowadays to transfer information. Copper telephone wires and computers run that. Wireless as well. Okay, so we've got lots of uses for electricity. All right, let's go back and talk a bit more about charge. So this is measured in units of coulombs, and it is a derived quantity. If you remember before, we had base quantities and derived quantities in the SI units. Electronic charge, so E minus, so it's sometimes used, referred to as an E minus. So the electrical charge on a single electron is 1.602 times 10 to the negative 19 C coulombs. Okay, so that means that 1 coulomb of charge is equivalent to 6.242 times 10 to the 18 electrons. So a lot of electrons to get 1 coulomb of charge. Okay, also the number of electrons associated with each charge of coulomb is this. So if we ever know how much coulombs we have and we want to work out the number of electrons, we just divide the charge Q by the number 1.6 times 10 to the negative 19, and then we get the number of electrons that way. And that is what we're going to do first here. So we have a plastic ruler, has a charge of 1.5 nano coulombs. How many excess electrons are on the ruler? So we have number of E electrons is equal to negative 1.5 times 10 to the negative 9. So check out your prefixes to get your nano. Is 10 to the negative 9. Divide by 1.6 times 10 to the negative 19. Let's put that into our calculator. So negative 1.5 times 10 to the negative 9 divided by 1.6 times 10 to the negative 19. Okay, so we get this negative number here, obviously because we put a negative charge in, but the negative charge just signifies that it's an electron. They are electrons rather than protons. So before I just said the electrons have a negative charge and protons have positive charge. That's just by convention. Someone just decided that long ago, and so scientists just decided that was the way we're going to do things, and so that's why we get this negative number here. But in reality, there are just a positive amount of electrons. So how many have we got? Let's see. So I'm just going to count up. We've got the 9, and they've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers after that. So, is that right? Let me count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we're right. So it's 9.375 times 10 to the 9 electrons. So it's a lot of electrons. That's 9.375 billion electrons. Is this static electricity or current electricity? Explain your reasoning. Well, it's static electricity. As it is a bit of a charge. And there is not a closed circuit. Like we said in our a continuous circuit, as we set up here. So it needs to be a continuous circuit for current electricity, and static electricity is a build-up of charge. So it's just a build-up of charge on the end of a ruler. Okay. Now that's a very large number. 1.5 nanocoulombs. No, that's a very large number of electrons anyway. Okay. So we'll leave it there for the moment, and we'll talk about electric circuits in the next lecture.